I do apologize. It looked like we were having some audio difficulties here. Is everybody hearing me, I hope? If you are able to actually hear me, go ahead and type it in here. I'm sorry, if you're not able to hear anything, just go ahead and make a mention in there as we move on. It looks like we're doing a lot better now. All right, let's go ahead and get started. My name is Alberto Masaroto, and I will be your host today. We'll be covering the basics of Creo Parametric. So before we get started, our agenda, a few words on who NextRev is, then moving on to our power hours and instructor-led courses, and finally talking about what is new in Creo Parametric 2.0, and on to our demonstration. So NextRev has been around for well over 10 years, working with PTC the entire time. We are also the largest reseller in the Western region and have offices from the Pacific Northwest to Southern California. We are also certified in all forms of direct modeling. We have well over, we actually have 8 application engineers from the Windchill line of products to the MCAD line of products, including direct modeling. We have power hours every single Friday. They range from what's new in Windchill all the way down to top-down design, Creo Elements Direct, and flexible modeling. If there is something that you are interested in, please reach out to us, and we'd love to hear what customers would like to gather some more information about. In terms of our courses, if PTC makes it, we teach it. So we are also one of the only people in the country that do offer classes into for direct modeling as well as Creo Elements Direct, which is formerly Co-Create. Moving on to Creo 2.0. So there's a number of new things that PTC has done for Creo 2.0. If you are familiar with Creo 1.0, the interface will look very similar. However, if you are still on Creo Elements Pro or Wildfire 5, you'll see quite a few differences. We do have an object called the Command Search, which I will talk about shortly, as well as our 3D Dragger tool. A number of changes in the model tree, as well as 3D selection. The measurement tool has been dramatically increased. Flat patterns in sheet metal is simply a touch of a button now. And the parallel as well as rotational blends are completely updated. There's a number of differences within our Style tool, and mind you, the Style tool is the interactive surface design module. Importing native SOLIDWORKS. If this is something that's valuable to you, I will be hosting a power hour tomorrow at noon all about SOLIDWORKS working with Creo Parametric. Dynamic cross-sectioning is brand new to Creo 2.0, and there's a number of ways to do it, as well as offering you a dynamically updating 2D view, which will show you and highlight any kind of interferences. These are also now stored in the model tree for rapid access. As much as I love talking, I think now we should move on to the demonstration. Just for a moment, I'm going to pause and make sure that there are no questions in my little box over here. It looks like everybody is doing well. Again, if there are any issues, please go ahead and type them into the chat box, and I will make sure that I take care of whatever is going on here. All right, well, let's move into Creo Parametric. Okay, so for those of you that are new to Creo 1.0 or Creo 2.0, obviously the interface is much different. This is very similar to the Office line of products. In fact, there's more than a passing similarity. This has actually been licensed by from Microsoft for Creo Parametric. So without further ado, I'll just kind of begin the demonstration here. What I'm going to try and create is an exhaust setup for a motorcycle. So what we're going to do is I've got a sketch here, and I'm going to simply create an extrusion referencing this sketch. All right, so I'll flip it around. You can see the dashboard interface is effectively the same as Wildfire 5. However, when we come to our swept blend, you're going to see major differences within this tool. So we're going to select our trajectory, and we are going to sketch on our start point. Okay, very simply, I'm going to project a loop, selecting this face as a reference. Obviously, later on when this face changes, it will automatically update. And we are going to insert a second sketch at the endpoint. So we'll go ahead and do that. And I'll put another circle in there of constant diameter, and we'll say it's 1 unit. Complete that. And here is our blend. Okay, very nice interface. No more menu manager. Very straightforward. So let's continue working on this. So I'm just going to do a extrusion on this face here. Not going to worry about the references. And again, I'm simply going to project off of this face and do an extrusion. Now what I found is, now this has been in the extrude tool for quite a while, but under options, you do have the ability to add taper on the fly. So we can simply say here, come in here, I'm going to make it 15 degrees. Again, this has been there a while, but I find that people do forget about the taper option in the extrude tool. Well, let's add some rounds. I'm going to put a round on this intersection, this one, and this end cap here. A value of 0.5 is fine. Looks very nice. Okay. Now what I have here on the right is the flange. So I need to make sure that from the flange we have some pipes that actually intersect this baffle. So let's go ahead and create some. I'm going to turn on my point display, and under datum we have a datum curve. So I'm going to use the datum points to drive the datum curve. So I'm going to start with this point here, holding control down to select multiple points. And what will be new to you, if you're not familiar with Creo 2, are these white balls here. If we right-click on those, it's going to give us a number of endpoint options. So I can say I want this normal, and then it wants to know, well, normal to what, and I'll select this surface. So we will complete that. And now with that still highlighted, we're going to go into sweep mode. And again, you're going to see quite a number of changes here between this and Wildfire 5. We can simply select our circle, complete that, make it 1.8. Okay. And that was it. Our start point was the first datum point that we selected in the creation, in the creation of the curve. When it was already highlighted, I simply asked it to do a sweep and sketched. Complete that. And now we will add an additional round on this intersection there. So what I'm going to do now is I'm actually going to group all these three together. And I am going to create a pattern. Now, you can see each pattern instance. However, I didn't tell it nor did I tell it was a directional pattern, nor did I give it a spacing. What's happening here is it's patterning based on a reference of an existing pattern or group. Okay, the pattern of the header over here was how I created this flange. So it sees a pattern on a surface and assumes that you want to do that. You don't have to, but it is going to assume that. In this case, that is correct. And there is my header. Let's make some changes now. The power of Creo Parametric is these late-stage design changes. So what I can do is I'm going to go back to my body over here, and I'm going to edit the definition of it. It's simply a sketch. Now, as you recall, this was the first object that I selected for an extrusion. So I am going to say, okay, well, I don't want that anymore. I actually want to have an elliptical shape. So we can simply create an ellipse. On this same sketch, select the circle, right-click, and replace, and select our ellipse. Complete that, and it's all updated. Now, because I asked this swept blend to be a reference to this feature here, it updated dynamically. All right. Well, we can see our header taking shape now. The last thing we need to do is actually not make it a solid object. We actually want to shell this out. So we have our shell tool. Now, if we can't find the shell tool, this little magnifying glass in the top right is called the command search. Everybody see that? If we expand this, and I just type in shell Shell comes up here, and if I hover over it, we can see that the Model tab has highlighted and Shell has highlighted. So the same is true as if I want to change the appearance. Well, in Wildfire 5, I knew how to change it, but in Creo, maybe I don't know. So I can just type in Appearance, and we can see that under Tools, we have Appearance Manager that shows up there. Because I typed in APP, Applications came up. If I'm looking for the Measure tool, same thing, okay? So definitely take advantage of the command search. So let's go to Shell, and I am going to omit this face here, and I'll make it, I don't know, 0.9. That's too big. 0.09 might work. There we have it. Okay, so we've shelled the entire object. Now, in order to double check to make sure that's actually gone well, we can go under View, and here is our Section tool. So this is our cross section. I'm going to do a cross section about, let's do the top plane here. And it is now dynamic. So if I drag this upward, we can see dynamically that we've shelled the entire feature. Now, if I save this, we are going to see the cross section here in the model tree. I can turn it on by right-clicking, or I can shut it off by right-clicking and going to deactivate. And there we have it. It's still visible in the View Manager, so we can go under here, and as you see, cross sections in the one I just created, so that will also be visible. Okay, so that is our basic core modeling. Now I'd like to move on to sheet metal. I'm going to double check, make sure there are no questions. Everything looks good here. And let's start with some sheet metal. All right, so if you are familiar with sheet metal, the first thing you're going to notice is that this isn't sheet metal. We've started with a piece of solid geometry. Think about it this way. We're working with a team that one of the gentlemen in there isn't too familiar with sheet metal, but what they are well aware of is that this is the shape of the object that they want. So now we can pass that on to someone that is more proficient with sheet metal, and we can then finish this part. So under Operations, we have Convert to Sheet Metal. And again, if you don't know where it is, you know it's called something sheet metal. Type in Sheet, and we can see that it's under Model, and then Operations, and Convert to Sheet Metal. So I'll select that from there. Select Shell, and just like we shelled that header, we can simply select this face to deactivate it, press Control, select that face, select this back face by right-clicking, and get rid of all that. I'll say a thickness of 0.08 is fine. Now note how the interface has changed into a sheet metal interface. Okay, so we have all new icons up here. You'll see some similar ones, sketches there, extrude is there. But now we have planar and unbend and bend and corner relief and conversion and on and on. So let's start doing some work. The first thing we're going to do is add a flange. So I'm actually going to change my filter to geometry and just select this, this back end or edge and this edge here. I'm going to click on flange, and it will create a flange on that edge I just selected. Now it is smart enough to realize that we can't bend this here with sheet metal, so it is going to omit that. Now let's add some relief. Right now it's going to default to a rip relief. That's not what I want. Under relief, we're going to find some options here, and I would like to do an obround relief. Okay. Now what we're going to see is that the preview has gone away. The reason it has gone away is that relief goes on the outside of the flange. And because there's a curve here, it's not able to do so. So what we're going to have to do is actually drag the flange in a bit on both sides, because we are going to have two obround reliefs. Okay, right there. I can double-click on that value and say I want to -5, or 0.5, excuse me. And notice how the flange wall has come back with our new relief. Okay. So I will complete that. And now I'm simply going to go to, under Model, we have Copy. And I'm going to expand, paste, and do a paste special. I'd like to paste a dependent copy on the other edge. Now paste is simply going to paste a variety of features that you have created. So I'm going to select that edge, press Shift, that edge, and that edge. But because, again, I did an ob-round relief, it wants to know, okay, well, we need to have some gap. So I can say there, and drag it up a bit as well. Also under length, we can see all the different types of offset. I can have it as a blind offset, a chain end, or even to a selected, just like an extrusion. So I'll make that from 6 to 5. Okay, and complete that. So now, if I had to change the height of this flange wall, I can just double-click on it and go, okay, well, instead of 0.96, let's make it 1.75, and you'll see that both sides are going to update. Okay. All right. Next, since we talked about a flange wall, let's put a flat on the other side here. So I want the flat, and I'm going to select this edge here. Now, if I accidentally select this edge, don't worry, you don't have to deselect anything. Simply hover over where the old edge was, and you'll be allowed to flip it back over. Now, there are a number of profiles here. There's an L, a T. We can even create a user-defined one that will point to an existing sketch. Let's do an L. And I'm going to set this up so that maybe this height here is 2. And this height here is 1.6, let's say. Okay. Now we have a problem here. All right. We obviously are having these two pieces of sheet metal intersect, and in the real world, they, we can't have this mass sharing the same volume. So what we're going to do is we are going to go under Shape, and this is the shape that we've created. We're going to actually sketch on it. It will allow us to sketch this flat walls profile within the actual or part that we're working with. So I'm simply going to add a line on this edge here. So I'm going to make this edge a reference. Now with Creo 2, by pressing Alt, it pauses the operation so that I can click an edge as a reference, let go of Alt, and there's my reference line. And now I'm back in the tool, select that edge or that edge right there, complete that, and I'm going to chop off this additional material, complete it. And now if this piece here changes its location, of course this sketch will update accordingly. So we complete that. Now if I want to see how the flat pattern looks, well, that couldn't be easier. We have an option right here that is going to show us our flat pattern. In fact, if we want to see the bounding box, well, that's just a click of a button there. And if you want to create our flattened instance, we can just click on this button here, and it will automatically create a flattened instance as a part of our family table. Okay, from here, let's continue messing with this part. Let's put in a notch right here, because there's a couple of things I want to show you about the flange tool that are pretty neat. So let's do an extrude on this surface. And what I'm going to do is just drop in kind of a rectangular feature here and give it some new dimensions. Okay, so I'll make it 0.5. And of course, it is going to automatically add the references. 0.5. All right. There's our cut. Now, when we add a flange wall, I'm simply going to select one edge. Okay. Let's actually select this edge here. Now, if I want to select all 4 of these, yes, I can go around here and press Shift and select all of them, or I can press Shift and select, now watch this, see, I'm on this surface here. Notice the perimeter. Highlights green. Okay, left click, and it will automatically create your entire extrusion. Now I'm going to complete this. Now I know those of you who are familiar with sheet metal are going to go, okay, well that was easy enough to make a flange wall, but we can't make this. In fact, if I turn on my flat pattern preview, it's not going to be very happy. It's going to say, okay, well nothing in this area is possible. So I'm going to go back to my flange and edit the definition there. I go, okay, well, the depth is definitely far too great, so let's pull that up here. And this kind of relief is also not possible. We can't stretch the material as we're punching it out enough to actually create this. So under relief, I can actually say a corner relief and say I want it to be an oblong. The thing is, some of these reliefs can take up a lot of memory, so there's an option here to actually create the geometry. So we've added the proper relief. The depth looks accurate. If I complete that, we're going to see our flat pattern update, and now it is more than happy. Next, let's add some different kinds of flanges. So I'm going to start with maybe a ducktail flange, and I'm going to place it right here on this edge. We drag it in just a bit. Okay, and we can also drag this one in here. Now, just like we did earlier, under length, we are going to see the different lengths we have here. So let's make this 1 and make this 11. Just using some round numbers, of course. What I want to point out, however, is that we can come in here and actually create offset on the fly also. So we turn offset on. Maybe give it by value, I don't know, let's make it 0.5. In the past, what we had to do was notch it out, which is one operation, then select the edge, then add the flange. It's a number of steps. Now we can do it all in one. And of course, our reliefs, we can come in here and say corner relief and do a oblong. Well, that's just, pardon me, it's a bend relief, and do an oblong. Okay, there we go. Looks nice. I'll complete that. And I'm going to pattern this. So we'll pattern it about this edge here, and I'll do 4 instances. Just going to eyeball it for now. Of course, this is just a demonstration. Let's complete that. And we have a problem. The object that I dropped in earlier, this rectangular feature, it's interfering. So obviously, we're going to have to go back and edit the definition of this part, see what value is going to work, or we can simply come in here and do a dynamic edit. So what we'll do is we'll just double-click on this feature. This is the drag handle for the depth. I'm just going to pull it up. No, not yet. There it is. Okay. Notice that flange just appeared when it was finally able to actually be created. So down, no, up, yes. That looks great, so I'm going to complete that. And here is my series of patterns. Now something a little different. We've done a lot of flat walls and flange walls. Let's actually go ahead and add a form. We'll start with a sketched form. So I'm going to select this top surface. And just to save time, I'll use my palette tool. Maybe pick like a racetrack. Yeah, that looks good. Drop it in here. Let's make that 0.75. Just going to eyeball the placement. I think that looks fine right there. And close. Okay. And that's it. So I just dropped in a sketch, and it's going to create the punch. Okay, so if we kind of just view this from both sides, you're going to see, okay, well, it did a punch, or actually a form. We really can't use this because we can't have these sharp edges, but that's okay. Under options, we can round the non-placement edges. Now, it is rounding both sides. We can also round the placement edges. Dynamically, of course, I can drag up the depth, and we can also add taper. So if we want to add some taper in like that, not a problem. If we want to make sure that the punch, that the form gets stuck, we can add some negative taper here. All right. We can also exclude a surface. So if I select this surface here, notice how the top surface shows up in exclude surfaces. I can complete that. And while that's active, I'll just go ahead and pattern it as well. And we'll do a directional pattern about this edge here. Maybe we do 3 instances. And we can say, in this edge here, we can come out this way. Of course, now we are going to get a failure with this hole here, so we can just omit that instance. Make a little bit wider, complete that. And here's our pattern of our forms. I would like to move on to the next examples. I'm just going to pause for a moment, make sure that there are no questions. Everything looks excellent. So let me close that up and talk about everybody's favorite files. Unfortunately, I can't see anybody, so if I said raise your hand if you love STEP or IGES files, most likely there would be no hands raised. Obviously, the biggest problem we have is they're difficult to edit. Yes, we can try and use feature recognition to refeaturize these tools, but ultimately it can be very problematic. So fortunately, we have a tool called flexible modeling. Now, this is going to allow us to do is very easily select a feature, for example, these series of five tabs. If we have to come in here with any other CAD tool and say, okay, well, this is the part that we have. Now we need to make these 5 tabs 6 tabs. All right, well, step 1, chop them off and rebuild them, because that's really all you can do. Well, with flexible modeling, we can just select the surface, select any kind of secondary surfaces that we want to as well, and go to pattern recognition. Now it sees, okay, well, there's 5 of these. Now they're all identical, so now we can turn them on or shut them off. However, what I'd like to do is actually add a 6th one. We'll do 6 at 60 degrees. Complete that. And that took about 2 seconds. Right. In any other CAD tool, without direct modeling capabilities, this would have taken us a little while. Okay, it's not that hard of a job, but we're engineers. We're paid to create. We're not paid to reinvent the wheel or the brake disc. On top of that, we can also say, all right, well, this is a pattern feature here. We can say pattern recognition once again, and it is going to pick up all these additional pattern instances. Okay. Now, I will go into some more depth with flexible modeling. So let's move on and talk about this piece here. So what we have here is just kind of the top of a flange, I would imagine. So what we're going to do now is we need to make some changes. As you can see here, it's just an import feature. That's all it is. I added a datum plane just to make this demo a little quicker. What I want to do is actually take this round kind of nozzle here on the end, right here, and I need to mirror that on the other side. Now, let's just for a moment think about what we'd have to do in a parametric modeling tool to take this and make another one. Well, I guess we would just, create a plane on this top surface, create a series of datum axes, and extrude downward up until this face here. Make sure that we add the round, and it might take us about 5-10 minutes to make that real fast. It's not that bad of a job, but we can do it. Well, let's see if flexible modeling can do any better. So I'm just going to select that whole object, click on Mirror, select, turn the mirror on, select this plane here, and that's it. Okay, it's going to mirror it. Not only is it going to mirror that feature, but as you can see, the bases are completely different. Therefore, when it mirrors it, it has to conform to the new surface that it's sitting on top of. So that took about 2 seconds. Okay. Next, we want to come in here and move this entire feature right here. So again, I'm just going to select that, and I'm going to drag it away. So just pull it to the right. Okay. Not too hard. The round's coming with it. But now we're approaching this end, this kind of drop off. Now what's going to happen? Most likely it's going to fail, right? In fact, it looks like it's going to fail now, but it isn't. Creo Parametric is smart enough to realize that with direct modeling, this is just a cylindrical feature. And even if the cylindrical feature just comes off the edge, the cylindrical feature is able to complete its regeneration. In fact, we can come in here and say, well, now it has to rotate a bit. And now it has to rotate maybe about this angle here. Now, in any parametric CAD tool, first things first, chop off this chop off this entire feature, and then create half a dozen datum planes to place this part, right, or place this feature. So let's complete that. And it's done. Now we have this hole left over here that we don't want, so I'm just going to select that surface and remove it. There you go, it's all done. I can even substitute. So this current piece here has this triangular shape, and I'd actually like to have it a round shape. So I created a surface right here, and I have a tool called Substitute. I'm just going to select the existing surface that I want to get rid of, or substitute, and say, okay, that's my existing one, and now I'm going to substitute it with this one. And there we have it. Okay, it's just a matter of telling what replaces what, and it is going to change all the rounds. The surface is going to change. This round is going to come along with the new shape, and that's all there is to it. All right. Next, we will talk about flexible modeling with a fully parameterized part. Now, this is a honest-to-God Creo parametric part. It's been designed in Creo parametric. All the features are here. So I need to do something very, very similar. I need to actually change the angle of this feature right here. So let me just go ahead and do that. The problem is, whoever drew this decided to create practically the entire part in one extrusion. So you can see extrude 1, the sketch that it's referencing is everything. Okay, it is basically everything's been drawn in one sketch. So to make a small change, I'm going to be pulling my hair out. I might as well just step it out, chop the piece out, and recreate it. It's just going to be faster. Or we can use flexible modeling. With flexible modeling, we can just say, okay, this surface and this surface need to move. However, you can see that I can really only move it in a linear fashion. I can't really move it about an angle. So what I can do is just turn on my axis and just say, I want to reference this axis. Now I can only rotate it. So I can say I need to move it by 6 degrees. Complete that, and everything is updated dynamically. And mind you, this is a fully parametric part, so that move that I just did is always going to be a parametric move, because I can come back here and edit the definition, and there we have it. So you can always go back and change it. Mind you, this cut here, which has been slicing through this whole top feature, has remained consistent. Even though we moved this feature to the right, we didn't change any of these relationships up here. Even something as simple as these rounds were created in Sketch. So if I actually wanted to edit these rounds, again, it's going to pull me up into that ridiculous sketch that we saw earlier. So I can either select them all or go to my geometry rules and search for objects of equal radius. And this is just a selection tool. I can say those are what I want, click on Edit Round, and change the radius. Okay. Couldn't be simpler. So even in a parametric model, flexible modeling has incredible power. I can even come in here and actually select this surface, modify its radius, and go, okay, I don't want it at this number here. I'll just make it 0.5 even, complete that, and it's all set. So it works incredibly well for incredibly poorly designed models, as well as very rigidly designed models. So with that, let's move on to some simulation. What I want to do here is add an arm right here that's going to attach this strut to this shock absorber. And what I actually want to do is I want to see the stresses that are being put onto all of these parts. So first things first, let's just see how everything moves. So if I select this steering arm here, you can say move it back and forth, move it up and down. But really, this upper strut is just kind of floating in space because there's nothing to actually align it to. So let's change that. I'm going to add a part here. It's called front rocker. There we go. And just plop it in space. Now this 3D dragger that we've seen a couple times, it's going to make life very easy, and you're going to see it all over Creo Parametric. All right, so let's just kind of rotate it and rotate it again. Just kind of eyeball where we want it. And that's pretty close there. All right. So what we're going to want to do is align this, this larger hole here with an axis. There is going to be a bracket here, but because this thing was built using master modeling techniques, we're simply going to use the skeleton to set this thing up. So we turn on my axis as well as my point display, and I'm going to use a pin connection. Now, a connection is not the same as a constraint. An assembly constraint is rigid. It's supposed to be rigid. A connection is a mechanical linkage. It's a mechanical attachment. So later we can actually apply loads, forces, frictions, motors, etc. to connections. We can't do that with constraints. So let's go to placement, and I'm going to say I want to align this axis with this axis. Now the part has vanished simply because it was not really near where we're supposed to go. So let's zoom back in here. And now to constrain this, this linear movement here, I'm going to align this datum point with this datum point there. Okay, so now we have rotation still, but there's no more translation. And next we're going to add a new set. The next feature that we are going to align is going to be this axis here and this axis. And we're also going to align now this center point and this center point, and they will now be all lined up. And lastly, we don't actually have to use the axes to actually get these lined up. We can select a face and a face, and then we are going to have to come in here and say this and this. And that gets everything lined up very happily. Okay, so we have 3 pin connections. So a pin connection is going to allow for rotation but not translation. So we can complete that and see if we did this properly. Let's use drag components. I'm going to select the strut, and we can see how everything works now. All right, so now it's going to stop at full compression and stop at full extension. It looks very good to me. Of course, we won't know until we actually complete the mechanism analysis. In order to do that, of course, we need to put a spring on this. Otherwise, the minute we put this car on the ground, it's going to flop around. So let's go ahead and add a spring. Under Applications, I'm going to go to Mechanism, and Spring is this little tiny guy right there. Now it wants to know from where to where. So I have a datum point here to start and a datum point here to end. There's my spring. We'll change the K factor to 10 and the U to 150. And I do want to adjust the diameter. It's not quite right. We need this to be 42. It's a bit larger now. And we can complete that. Now if I use drag components, let's check this out. We can grab this arm here and fully compress, fully extend. Now tell me that's not sweet. There we go. Okay. So now we have a fully operational suspension arm. So what I've done here is I added 2 motors. One motor for the suspension and one motor for the steering, so that we can see it run through all of its forces. So that under motors we can see motors, servo, and I have steering and I have suspension. And under analyses, let's open this up, we are now going to run a dynamic analysis. So what we're going to do under motor here is actually click on run. And what's going to happen now is, I'll try and get this all on the display here. The motors, both of them, one for the steering as well as one for the suspension, are going to run through their motions. At the bottom of the display, we can see the percentage of the way it is through it, but it's going to go from full stop on steering to for both directions, as well as full stop and, for the suspension. Once it has completed this, because we've given the spring a number of values, then this is not just a helical spring. This is a physical suspension component. The next thing we're going to do is run the analysis and see the forces that are actually being applied when it's under full load and when there's when it's under full extension. This will give us a really good idea of how the suspension is going to actually work in real life. Now this is nearly completed, so the minute that is done, we are going to actually go to the measure tool in the ribbon and go from there. Okay. So the measure tool is right here in the ribbon, and what we're going to do now is actually apply values to F1 through F3 with relation to the dynamic results that we just calculated. So F1, I'm going to double click on that and say that F1 is this feature right here. Okay. So that feature happens to be connected to the car body, so it's a fixed entity. So okay. Feature 2 is going to be this piece here that attaches to the strut. And feature 3 is going to be this feature here that attaches to the spring. Okay, so those are all 3 of those. And now what we're going to do is select all of them. So there's that, that, and that. Now I am holding control, by the way. And now we are going to actually click on the graph. Okay, the graph, by the way, in case you didn't see that, was here in the top left. So I can close this box. I do want to keep the graph tool open. And now what we're going to do is actually run through the playback. Okay, so we can see how this performs. And just to kind of tidy up the graphics, I'm going to get rid of those datums. Now, what I want to note is that the loads can be displayed. So we have actually display arrows. So if I turn these on, we can see the loads. The larger the arrow, the larger the load. These are kind of ridiculously big, so let's make them a bit smaller. Let's make them 30% of that. Force down a bit. Okay, so now we can see them. Mind you, there's no collision here, but if you did have collision, there are some collision detection settings here as well. So let's play this current set. Try and make some room here. And play. All right. As we can see on the left, as the suspension is compressed, the vertical load on the strut increases. However, as the suspension lets down, the load on that strut decreases. And again, suspension goes up. The fixed point on the chassis also increases. So no surprise, the more load placed on the suspension, the greater the force is placed on the strut, on the spring, on the shock absorber assembly, as well as on this cantilever arm. On the right, with the graph, we can see at which point exactly we have this this peak here. Okay, we have the measure on the left, and we also have the times on the right. On the bottom, we should have changed the colors maybe here, but you can see the force at F1, the force at F2, and the force at F3. This, of course, all can be exported to Mechanica. That will be a different webcast, but I did want to get to this point here to show how the setup was for this particular simulation. All right, at this point here, I'd like to start to wrap things up, so we'll kind of do a little summary of what we talked about. Okay. With our core modeling, we saw some of the new features in Creo Parametric, such as the sweep as well as the swept blend tool, all dashboard driven, no more menu manager. We saw Creo's ability to automatically recognize an existing pattern and pattern on top of that, as well as using the replace function to take a circular feature and turn it into an elliptical feature. Now this is all set up so that we were using Creo's ability to basically reference an existing feature, and as that feature changes, for example, a circle to an ellipse, the sweep or the blend is going to change dynamically. Speaking of dynamically, we saw the dynamic cross-sectioning, and from there we jumped into sheet metal. Talked about how we took a solid piece of geometry and turned it into a piece of sheet metal. We then saw copy and doing a paste special to create a feature that had intelligence, so that if one was updated, they all were. We did a rectangular cutout and added some corner reliefs. Saw the flat pattern display, as well as talked about how to create a flattened instance. Dynamic edit to edit a feature in 3D mode, and actually saw it update the pattern instance that initially was failing. And we also talked about forms and creating sketched forms and turning on or shutting off certain pattern instances. Then we did a little bit of evolutionary and late-stage design changes. Late-stage design changes are always going to be those changes that take us the most amount of time. They're the ones that have, had projects go out late, had us waste tons of engineering time, completely redesigning models, or even worse yet, taking a completely finished model and turning it into a step file and then editing it because that was easier. That is no longer the case with flexible modeling. This is a direct modeling tool, therefore it only is concerned about geometry. That is why it is able to work with step and IGES files. On top of that, we finished today's presentation with some structural simulation. So we talked about how to actually do an assembly. That was simple enough. We did a 3D dragger. We did use a series of axes and datum points to align everything using connections as opposed to constraints. We used a mechanism to create a spring which was able to apply forces, and then ran it through a series of dynamic tests to see what the forces were at a series of times depending on the motors that we applied to both the steering as well as the suspension. And from here, we can then bring it into Mechanica and get some results and stress tests on that arm. So that was Creo Parametric, the basics. I will open up for some Q&A time, but I just did want to remind everybody that June 20th, we are going to do Creo Elements Direct, the basics. This is formerly Creo, excuse me, this is formerly Co-Create, which was formerly ME30 and ME10, developed by Hewlett-Packard in the early 80s. So it's a fantastic direct modeling tool, and that is where Creo Parametric is getting all of its direct modeling capabilities. We are going to basically have what you just saw as a hands-on workshop. If you've been to one of our hands-on workshops, then some of this demonstration looks very familiar. If you have not been to our hands-on workshop, it is basically what I've talked about. You can come to our office. We're going to be having a number of them in San Diego, LA, San Francisco, most of the Bay Area in Northern California, as well as East Bay. And of course, we are located in San Jose, so we will be hosting those very often at our facility. The hands-on workshop is everything that I have covered, except you'll be doing it yourself. It is a 3 to 4 hour engagement, and we go over quite a bit of Creo Parametric functionality. If you are interested, please reach out to our sales team at sales@nextrev.com or speak to the sales representative that informed you of this webcast. I'd like to open up the floor for some questions. There is a question dialog box here. There is also, in fact, I do see a question there. I just have to kind of expand this a bit. Is this demo on file for future viewing? It will be on file in a couple of weeks. We'll have a link to our saved webcasts on nextrev.com. Okay, any additional questions? Again, there is a question dialog box. If you can't find that, there is also a chat dialog box. So I'll gladly go ahead and answer anything on those two right there. Okay, we have a question here on turning solid models into sheet metal. Okay, the operations tab, under the operations tab we have convert to sheet metal. That is out of the box. Everybody who has Creo Parametric is able to use both sheet metal as well as convert to sheet metal. Does that make sense? Is that your question? Okay. The question's been asked, how do you convert things to sheet metal that can't be converted to sheet metal? So I think I see what you're saying. Just because we've shelled an object out isn't going to give you the ability to actually flatten that object. Therefore, there is a conversion tool that will add rips, rip reliefs, corners, and a number of other objects that have kind of that are escaping me at the moment. We are going to have a power hour specifically on converting objects from solid to sheet metal coming up. So please keep your eyes posted on our webpage, which in fact I'll show you. Let me scroll back up there real fast so you can see what the power hour webpage is. Okay, it is under nextrev.com/training/power-hours. Any additional questions? All right, it looks like that is it. Well, thank all of you for joining our webcast today. Sorry for the little hiccup this morning for the login. We'll make sure that does not happen again. Again, if there are any questions, please go ahead and email the sales representative that contacted you about this. If you're not contacted by anybody, please go ahead and email sales@nextrev.com for any additional questions that you may have. Again, thank you very much, and I hope to see all of you on our June 20th Creo Elements Direct The Basics webcast. Thank you very much.